Hi, I'm Jon Eivind Vatne at Bergen University College. In a recent paper, Christian Cassel and Christoph Reutner discussed the zeta function of the Hilbert scheme of endpoints in the two-dimensional torus. And while they were investigating this zeta function, they came across a question in elementary number theory. So one of the coefficients of the zeta function turned out to be given by the sequence of middle divisors. Cassel and Reutner asked whether this sequence is unbounded or not. So a middle divisor of n is a divisor close to the square root of n. More precisely, it's a divisor in the range from the square root of n half to twice that number. And in this short note, my goal was to show that this sequence is in fact unbounded. I do this by exhibiting an n, or a sequence of n's, with many divisors in this interval. So to choose n, I start with two consecutive integers, I and I plus 1. I let n be I times I plus 1 to some high power, high even power, multiplied by 2. Then the square root of n half will be an integer, and it will be a divisor of n. Also, the square root of n half will be of the form I times I plus 1 to some power. Now this means that I can keep multiplying by I plus 1 divided by I, so that three conditions are satisfied. The product is an integer, it divides n, and it's less than the upper bound for the range I'm interested in. Of course, I can keep multiplying by I plus 1 over I as long as I plus 1 over I to some power is less than 2. As I tends to infinity, I plus 1 over I tends to 1, so I can multiply more and more times and still be less than 2. So this exhibits an infinite number of n's with a growing number of middle divisors. And the proof is concluded.